In this video, we will be solving GCE ordinary levels chemistry, MCQ paper 1, June 2021. But before we continue with our topic today, I want to appreciate those of you who have taken your time to subscribe to our channel. You have really motivated us to keep on assisting you people by providing necessary solutions for you to prepare for your exams. But for those of you who have not subscribed, please motivate us by taking your time to subscribe to our channel. But do not go without hitting the notification bell. Thank you for taking your time to subscribe to our channel. Let's go straight away to question number 1. Name a metal that is extracted by thermal reduction. A. Aluminium. B. Copper. C. Iron. D. Sodium. From all investigation, the only metal that is extracted by thermal reduction is copper. B is the right answer, is copper. Copper is the only metal that is extracted. Copper. 2. Oxidation can be defined as A. The gain of electron. B. Addition of hydrogen. C. Loss of oxygen. D. Addition of oxygen. Remember that oxidation in terms of electron transfer, we can say oxidation is loss of electron. We can say oxidation is loss of electron. Or we can say oxidation in terms of oxygen, we can say addition. Oxidation is addition of oxygen. Addition of oxygen to a compound. To a substance or to a compound element, and etc. So it's addition of oxygen to a substance. And now let me give you a small equation to show that oxygen is the addition. We can now say this is iron 3 oxide. Let me say iron 3 oxide plus this one to give iron plus 3 carbon dioxide. Let me balance it 3, and I can use this to say from here from iron, then from carbon, there's oxidation. This is oxidation and this is reduction. This is reduction. From here you can see that this is the addition of oxygen into a compound. Addition of oxygen to a compound. So this they have now addition of oxygen to a compound. This is what we call oxidation. So if we go back to our equation, to our question number 2, oxidation can be defined as addition of oxygen. So question number 2, we will say question number 2, D is the right answer. Addition of oxygen. You have seen it well clearly here. Okay, now question number 3. Identify the change of state from solid to gas. From solid to gas, what is the change of state? A. Sublimation. Of course, sublimation is when you leave from solid directly to the gaseous state. B. Evaporation. That is not the thing. That is liquid. Melting. Melting is from liquid. From solid to liquid. And fusion. So now the right answer, according to the question, identify the change of state from solid to gas. The right answer is sublimation. That is A. Question number 4. Which of the following is the main component of inactive air? Of course, inactive air, argon is not inactive air. We have argon, nitrogen, oxygen, and carbon dioxide. The only inactive air here is nitrogen. The air comprises of oxygen, nitrogen, and nitrogen is the word inactive air in air. So B is the right answer. And number 5, identify a species which is an isotope of 3517X. What is an isotope? An isotope, first of all, you must know the definition of an isotope. An isotope, isotopes. These are, we can say, these are atoms of the same element, having the same proton number, or what we call the atomic number, but different mass number. And the difference in their mass number is as a result of differences in the number of neutrons. So we need to look for an isotope that have the same proton number, or the proton number, or the same atomic number. From A to D, which one is that? Which one has the same one? It cannot be A, because A is the same thing like the isotope that have been given. It cannot be B, because it has a different atomic number or proton number. It cannot be C. It cannot be D, because it has a different proton number. It can only be C, because it has the same proton number. So number 5 is C. Number 6. Explain why hydrogen gas is collected by upward delivery. Upward delivery is when something is collected over upward delivery. It means that it is lighter. It is lighter. It is lighter. It is collected by upward delivery and downward displacement, because the air would displace the hydrogen upward. Hydrogen is less dense. Any gas that is collected up in upward delivery, it means that it is less dense. It is lighter. It is lighter, or it is less dense. For that purpose, it will the air will displace it. It will be displaced, and because it is lighter, it will be collected in upward delivery. So our answers now say: 1, it is heavier than air. No. B, it easily displaces air. No. C, it is lighter than air. Yes. We don't need to go further. So it is lighter than air. So learners, if you want for these multiple choice questions, read the question, interpret the question, look for the answer before visiting the answers, because if you go directly to the answers, you may not think. Read the question, think critically, deduce the answer before sorting out the answer from the answer column. Okay, question number 7. Which of the following anions will form a precipitate with barium chloride in acid medium? In acid medium, the only anion that can form it is barium um, with barium chloride is sodium sulfate. For instance, it's sodium sulfate. It's only sodium sulfate that can do that. For question number 7, sodium sulfate is only sodium sulfate and is the sulfate ion. Sodium, not sulfite. Sodium sulfate is sulfate ion. So which the sulfate ion will come from sodium sulfate. So it is the sulfate ion that will come from the sodium sulfate. Okay, question number 8. How many more molecules are there in 4.5 grams of water? Okay, we are now going to go into our calculation. How many molecules are there? How many molecules? Okay, we will use the Avogadro number or constant to calculate. 4.5 moles of water is equivalent to 4.5 for here 4.5 gram of water divided by the molar mass of water, which is 18 gram per mole, will give us 0.25 moles of water. So in this case, we can now say if 1 mole of water, which is 18 gram per, 1 mole of water, 1 mole of water can give 6.02 times 10 to the 23rd molecules. Then, because they have said how many molecules are there, so the particles there are molecules. If 1 mole of water can give 6.02 10 to the 23rd molecules, then the mass that was given, that has been converted to mole, is 0.25 moles of water will give X. And what will be X? X will be cross multiplying it. That is 6.02 times 10 to the 23rd, times 0.25 will give us 1.5 times 10 to the 23rd. And if we check on our answer column, D is the right answer for question number 8, molecules. So that is the right answer. You have to convert the grams into the moles, and then you do your simple proportion. Thank you. Question number 9. We have to go to question number 9. Identify the gas that naturally makes rainwater slightly acidic. For rainwater to be acidic, acidic rainwater, it cannot be sulfur dioxide. It can be sulfur dioxide because sulfur dioxide is an acidic gas, and it will make rainwater more acidic, and the pH will be really between 2 and 3. It can be hydrogen sulfide. It can be nitrogen dioxide, because nitrogen dioxide is purely acidic gas too, and it will make the rainwater acidic. But carbon dioxide is not too much acidic. It will make the water to be slightly acidic. So the normal rain, remember that normal rain has a pH of about 5.6 because carbon dioxide has dissolved in it. So for it to be slightly acidic, to be acidic, we have a pH of 1 to about 3 point something. But to be slightly acidic, it must have a pH of about 5 or 5.6. And that is when carbon dioxide comes in. So carbon dioxide only makes it to be slightly acidic, not acidic, slightly acidic. That is why carbon dioxide is not fully included among the list of acidic gases. Is only slightly acidic. So the only gas that naturally makes rainwater slightly acidic is carbon dioxide. And our answer is a B. Question number 10. Select a diabasic acid from the list below. We have hydrochloric acid, nitric acid, sulfuric acid, and we have ethanoic acid. What is a diabasic acid? That is the thing you have to know before answering the question. In trying to diagnose, trying to digest this answer into to have the question, to have the question, to have the answer. Sorry, you have to think critically. What is a diabasic acid? A diabasic acid is acid that has two hydrogen atoms. Acid that has two hydrogen atoms that can be replaced by a metal ion. It is an acid that has at least two hydrogen atoms that can be replaced by a metal ion. And if we go to our answer column, the only one that has at least two hydrogen atoms is sulfuric acid. So a diabasic acid here is C. Question number 11. Determine the number of neutrons in an atom of A. A has a mass number of 40 and a proton number, or what we call atomic number, of 18. What should be the number of neutrons? I told you that neutrons, the difference in the number of in the mass number of an isotope is neutron. So the mass number is a combination of the proton number and the number of neutrons. The mass number is a combination of the proton number and the number of neutrons. And if we do this, we will see. You will see that for 40, mass is equal to proton. And I will say proton plus neutron. The proton is what we call the atomic number, please. Now we are looking for the number of the number of neutron. Neutron now will be what? Neutron now will be equal to mass, the mass number minus what? The proton number. The proton number. And here our mass number is what? Is 40. 40 minus the proton number or the atomic number is what? 18. Therefore, our number of neutrons will be what? 22 neutron. We have 22 neutrons. And the 22 neutrons, if you go now to our answer column, 22, no, that is, the answer is D. Question number 12. Question number 12. For the reaction calcium carbonate plus dilute hydrochloric acid, we will have calcium chloride plus carbon dioxide plus water. The rate of reaction can be increased by A, placing the reaction mixture in an ice bath. No. B, grinding the calcium carbonate. You know, when we grind the calcium carbonate into powder, we increase the surface area, and increasing the surface area of a reactant increases the number of collision, and increase in the number of collision will lead to increase in the rate of a chemical reaction. So B is the right answer. Question number 13. Which of the following salts will give a brick red flame? Using flame test for the salt, we have calcium carbonate, we have sodium carbonate, we have barium sulfate, we have potassium sulfate. The only one that will give a brick red is the only ion that can give brick red is the calcium ion. Only calcium ion will give a brick red. Only calcium ion. Calcium ion gives a brick red. Calcium ion. As a calcium ion gives a brick red. So in that case, the compound that contains calcium ion is A. So only calcium ion can give a brick red color. Gives a brick red color, yeah, under the flame, under the Bunsen burner. Question number 14 and 15 concerns the following diagram. There is a diagram here that gives solid X and a boiling tube, and it is being heated. A gas is being released, and the gas gets into another tube containing lime water, and the lime water turns the gas milky. The question now reads, question number 14, identify the solid S. Remember, I said read the question, diagnose it very well, and now deduce possible answers before visiting the answer. So now, the only substance that can give a lime water is a carbonate. And in this case, it's a carbonate. And in this case, there are two carbonates here. Which of the carbonates will give carbon dioxide? Now, is it sodium carbonate or is it calcium carbonate? The most possible is a group 2, the calcium carbonate, that will give carbon dioxide when it decomposes. So the answer is D. And number 15. Number 15 is why does the lime water turns milky? Of course, if you look at a reaction, lime water is calcium hydroxide. Lime water is calcium hydroxide. If lime water reacts with carbon dioxide, for instance, let me say this is a reaction, calcium hydroxide when it reacts with carbon dioxide, calcium carbonate plus water. Remember, calcium carbonate is white in nature. It is white in nature, and when the calcium hydroxide now reacts again with carbon dioxide, it reforms back the calcium carbonate. So we can now say, because the answers are B. Why does the lime water turns milky? A. Solid A is white in color. Solid S is white in color. B. An insoluble salt is formed. An insoluble salt is formed. It's not that it's a salt. An insoluble salt is formed. The answer is an insoluble salt is formed. That is the calcium carbonate. So our answer is B. Is formed. An insoluble salt is formed. That is the reaction. Insoluble salt is the calcium carbonate. Okay, now question number 16. Question number 16. Compound X is bubbled. Compound X is bubbled through a solution of aqueous bromine. The reddish brown solution is decolorized. Now. Remember that a solution of a solution of aqueous, remember that a reddish brown solution is, bromine water. A reddish brown solution is bromine water. And bromine water, very well, bromine water will decolorize alkene. Bromine water, that is a test for alkene. Only bromine water will decolorize alkene. And now we are told X is bubbled through a solution of aqueous bromine. The reddish brown solution is decolorized. D is bromine water. And it is the only one that can decolorize alkene. And S could be, you have to look through the answers to see which of them is an alkene. A is alkane, B is ethanoic, is carboxylic acid, C is ethanol, D is an alkene. So the answer is D. Why? Because it is an alkene, and only bromine water would decolorize alkene. Question number 17. Which of these contains the same number of particles? The same number of particles. Question number 17. Now, number of particles, they has to do with it has to do with the number of particles. We have to do that with what we did the other time. Okay, number of particles here. Which of these contain the same number of particles? A, 1 mole of water and 40 grams of sodium hydroxide. One mole of water. Which of these contain the same number of particles? Okay. Avogadro's law states that in Avogadro's law, 1 mole of a substance contains 6.02 times 10 to the 23rd power particles. So only 1 mole of a substance, of any substance, will contain that number, according to Avogadro's law. Only 1 mole of a particular substance that will contain that number, the number of particles. And if the number of particles is not up to 1 mole, it can't contain that. And we are told which of these contain the same number of particles. Now, 1 mole of water is equal to 18 grams, and 40 grams of sodium hydroxide. The molar mass of sodium hydroxide is 40. That is 23 for sodium, 16 oxygen, and 1 for hydrogen, making a total of 40. So this is 1 mole and this is 1 mole. Therefore, 1 mole of water and 40 grams of sodium hydroxide will contain the same number of particles, which will be 6.02 times 10 to the 23rd. And we say our answer is right. A. Number 18. What is the color change when 2 drops of phenolphthalein are added to a solution of sodium hydroxide? When you are about to do titration, you need to add an indicator like sodium, phenolphthalein indicator into the base. And now they are asking us, what is the color change when 2 drops of phenolphthalein are added to a solution of sodium hydroxide? When you pepper 25 cm cube of sodium hydroxide into a conical flask, it is colorless. And the phenolphthalein indicator is also colorless. So when phenolphthalein indicator is dropped into the conical flask containing sodium hydroxide, the color changes to pink. So 18 is pink. That is B. Number 19. Number 19. Use the equation ethene plus water plus oxygen to give carbon dioxide plus water. That is enthalpy of combustion, and we are told calculate the heat evolved when 2.8 grams of ethene are completely burnt. Okay, we don't need to be drawing. We will not use Hess's law here because we have not been given the enthalpy of combustion. We have not been given the enthalpy of formation. We have not been given the enthalpy of formation of ethane and other things like that. So now calculate the heat evolved when 2.8 grams of ethane are completely burnt. Now we have been given only the heat change. We have been given only the heat change during when 1 mole of ethane is combusted. Okay, let's see how we can solve this. Now, the question says, from this question here, if one mole of ethane, if 1 mole of ethane from the reaction, 1 mole of ethane, ethane is C2H4. If 1 mole of ethane can produce or produces, we can say produces minus 14 10 kilojoules. Yes, kilojoule is kilojoule per mole. Now, then 2.8. We are said 2.8 gram of ethane. 2.8 gram of ethane will be 2.8 gram of ethane is like 2.8 gram of ethane. The molar mass of ethane is 28. 2.8 gram of ethane is the same as 0.1. It's the same as 0.1 mole. 0.1 mole ethane, C2H6, H4, will produce it's a matter of cross multiplication. 0.1 times minus 1410, which is supposed to be minus 141 kilojoule. It's kilojoule. Now it is minus 1, but now remember that this is combustion. Remember that this is a combustion reaction. A combustion reaction is an exothermic reaction. A combustion reaction is an exothermic reaction. So we need to do what? We need to add a negative sign there. We need to add a negative sign there, which will now be equals to what? Will be equals to negative 141 kilojoule. A combustion reaction is an exothermic reaction. Why? Heat is being released, and anything that is exothermic has a negative sign. So now this answer is supposed to be this is the answer. But remember that exothermic reaction is what? Exothermic reaction is combustion reaction is exothermic. So we add a negative sign there. Our answer now will be what? Negative is positive, which will be 141 kilojoule. We go now to our answer column, and see if we can get the answer there. Now coming here, question number 19, yes, D is the right answer for us. D is the right answer. Question number 19, D is the right answer for us. Question number 20. Question number 20. Name the apparatus that is used in the laboratory to measure the temperature of a liquid. Obviously, you know it's a thermometer. A thermometer. Thermometer is used for the measurement of temperature. So it is not cylinder, is not ammeter. Ammeter is not burner, it is a thermometer. B is the right answer. That was a cheap one for you people. Now, I say question number 19. D is the right answer. Okay. Okay, question number 20. Name the apparatus that is used there. I say it's a thermometer. Question that is B. Question number 21. Question number 21. The compound ammonium sulfate is commonly used as a fungicide, a cleansing agent, a fertilizer. You know this ammonium sulfate. Ammonium sulfate is NH4SO4. There, nitrogen is the salt is used to generate nitrogen. This NPK fertilizer, we have nitrogen, we have phosphorus, and we have potassium. So nitrogen is got from the ammonium sulfate when it is used as fertilizer. So now C is our answer. Question number 21, C is our answer. C is the right answer. And question number 22. Question number 22. We are so 22, 23 concerns the following diagram. The diagram here, 22. The diagram here gives us something on decaying. Decaying is decaying has to do with 10 carbon atom. That is 10 carbon atom, alkane. Octane has to do with 8 carbon atoms, alkane. And ethene has to do with 2 carbon atoms, and that is an alkene, not an alkane. And then X. So now a decane undergoes a certain reaction P to give octane and ethene. And the same ethene, X undergoes dehydration to produce ethene. Identify the process P. You know that in this you should know here that in this type of reaction, decaying is like, it is C10, since it is C10H22, because it is an alkane. Now it will undergo a particular reaction to produce octane, which is C8H18, then plus ethene is C2H4. Then there is another element that undergoes something here that undergoes dehydration, and in that case I will call it ethanol. Ethanol is CH3CH2OH. It will undergo dehydration to produce this. That is minus water. Here we have minus a molecule of water. Here, that dehydration occurs is we use concentrated sulfuric acid at temperature at 170 degrees Celsius. Yes, when we use this, we will remove a molecule of water and ethane is produced. And this is this. So here, what will usually happen here is cracking. There's what we call cracking here. Usually thermal cracking. Thermal cracking that will result in these two. Thermal cracking will result in these two. So cracking is another method we will use to produce lower alkanes, or to produce lower alkanes and alkenes. So now let's go back to our question. The question now says, identify the process P. P is cracking. P is cracking. That is question number 22. P is cracking. That is A. Now, again, identify the compound X. The compound X that went through dehydration is ethanol. The compound X is ethanol that went through that. It is ethanol. There it is. We have ethane. This ethanoic acid is ethanol. So D is the right answer. Now, question number 24 has to do with the following reaction is used to manufacture ammonia. We have nitrogen plus 3 moles of hydrogen. It is a reversible reaction that gives 2 moles of ammonia. All are gaseous reaction. The reaction is exothermic. From the enthalpy change here, it is exothermic. Now, which of these changes will increase the yield of ammonia? Remember, for exothermic reaction and being a gaseous, all are gaseous reaction. Increasing the pressure here, since there are 2 moles on the right and there are 4 moles on the left, increasing the pressure, the equilibrium will shift to the area of lower number of moles, and in that case the equilibrium will shift to the right. And if the equilibrium shift to the right, we are saying that more ammonia is going to be produced when we increase the pressure. It's not by decreasing pressure, no. It's not by increasing temperature, no. It's not by using a catalyst, no. It is by increasing pressure, because when we increase pressure, equilibrium will shift to the right. And when equilibrium shifts to the right, more ammonia is being produced. In that case, our answer for question number 24 is D. That is according to Le Chatelier's principle. Question number 25. On question number 25, identify a metal which is used to make kitchen utensils and also in the construction of aircrafts. The lightest metal that is used is not copper, it is not titanium, it is not magnesium, it is aluminum. Aluminum is lighter. There's one advantage of aluminum: it is lighter, and it is abundant in the earth's surface. It is lighter, that can be used for the construction of aircraft, even vehicles, and the kitchen utensils. So aluminum metal is the one. So we take answer B. 25 is B. Question number 26 has to do with gas laws. Question number 26 has to do with gas law. Okay, the behavior of some gases is represented by the following graph. They have volume against 1 all over P. Identify the gas, the law represented by the graph. Is it gas law? Is it Charles law? Is it Boyle's law? Is it Avogadro's law? Now, it is Boyle's law. This is Boyle's law. Boyle's, that is Robert Boyle. Robert Boyle is a scientist. Robert Boyle in 1662, if I can still remember, stated in his law that The volume of a given quantity of gas is inversely proportional to its pressure at what? Provided the temperature is constant. Again, he said that the volume of a given quantity of gas is inversely proportional to its pressure, provided the temperature is constant. And Robert Boyle stated this again. This is how he puts this. V is directly proportional. V is directly proportional to 1 all over P. That is how 1 all over P. That is how he puts it. O, we can now say the O, this can be written as P is directly indirectly proportional to 1 all over V. If we cross multiply this, we will see that PV is equals to T. And if PV is equals to T, we are now saying that the initial values will be, let me say, P1, V1 is equals to P2, V2. And that can be represented in this form again. If we take our value here using this same, here we say, let's say this is a volume and we want to make it. You will see here that this volume, this is the volume. You see the volume, see the volume, and look at P, and the P. We are saying that as the volume is decreasing, the pressure is increasing. As the volume is decreasing, the pressure is increasing. Volume is inversely proportional to the pressure. That is Robert Boyle's law. For the purpose of revision, it is the same way like Charles' law, which is different from Charles' law, that states that the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature, provided the pressure is constant. For Charles' law is the opposite. Charles' law is opposite. We say it is V is directly proportional to T. In that case, V is equals to T. And we are saying that it is V1 all over T1, which is V2 all over T2. So that is, as the volume increases, the temperature also increases. Unlike in Robert Boyle's law that says the volume of a given mass of gas is inversely proportional to its pressure provided temperature is constant. As the volume decreases, the pressure increases. In that case, our answer is C. Our answer is C. That is question number 26. Question number 27. Question number 27 will go to, what will you observe at the cathode when, what will you observe at the cathode? What will you observe at the cathode when aqueous ammonium sulfate is electrolyzed using graphite electrode? Graphite electrode, that is inert electrode. Now, at the cathode, you should know that. At the cathode, you should know here that at the cathode, what is seen at the cathode in this way is this. At the cathode, you will see that this is the cathode, and this is the cathode, and this is the anode. That is the cathode. The cathode is negatively charged, and this one is positively charged. At the cathode, we have this copper. There are two ions. There are two ions, copper ion and a hydrogen ion. And here we have OH ion and what we call the sulfate ion. So here, the one that is discharged based on the electrochemical series, that is low, that is very low at the electrochemical series, here that will be discharged at the cathode is this one, and this other one is OH is the one that will be discharged. And if calcium, if copper is being discharged, the equation will be what? Here it will be copper. What we will have here at the cathode will be copper 2 plus, which is aqueous 2 plus 2 electrons, to give what? Copper will be deposited as copper solids. Then at the anode, what will be deposited at the anode? At the anode, oxygen will be deposited at the anode. In that case, we will have OH, which is aqueous, to give oxygen, which is a gas, plus oxygen plus water, and plus what? Yeah, four ions that are there, 4 electrons. So we have oxygen that is being released at the cathode, at the anode. Balance our equation. So now at the cathode, we are interested in what is at the cathode. At the cathode, what is going to be copper is going to be deposited. Copper is going to be deposited at the cathode. And if we go now to our answer column, and our answer column now, what will be at the cathode? The question says, what would you observe at the cathode? What will you observe at the cathode when aqueous copper 2 sulfate is electrolyzed using graphite electrode? The cathode is colored brown. The cathode reduces in size. The cathode cannot reduce in size because copper is being deposited at the cathode. The cathode is plated with copper. So the only possible answer with the cathode will be A. Copper is deposited at the cathode. Now, question number 28. Carbon dioxide is heavier than air. The gas is collected in the laboratory because I said the other time, any gas that is heavier than air, there must be that displacement. If it is heavier than air, it's going to displace air. So it's now going to be collected by downward delivery because it is heavier. It is more dense than air. So it is downward delivery. It's going to displace the air. Air will go up and the carbon dioxide will come down. So now is downward delivery. I said excuse me. Remember I said excuse me, gases that are heavier than air would be collected by downward delivery or by using what we call a gas syringe. Any gas that is heavier than air would be collected by a downward delivery or by using a gas syringe. Question number 29. 29 to 31. For each of the questions, one or more of the responses given is or are correct. Decide which of the responses is or are correct. Then choose A. A is 1, 2, and 3 only, B is 1 and 3, C is 2 and 4, and D is only 4. Now we go to question number 29. Which of the following equation represents thermal decomposition? Ammonium, yes, it will undergo from solid thermal decomposition to ammonia and this, and the hydrogen chloride gas. That is thermal decomposition. That's right. That is right. Sodium carbonate plus aqueous hydrochloric acid. This is a reaction, not thermal decomposition. So the number 2 is out. Number 3, calcium carbonate is solid. This is a thermal decomposition into calcium oxide plus carbon dioxide. calcium oxide into carbon dioxide. Yeah, this is a thermal decomposition. Sodium chloride is aqueous. It is aqueous in water. It cannot undergo decomposition, thermal decomposition in water. No, it is not the ions. That's not how it will. It's a reaction. So in that case, we will have only 1 and 3, and 1 and 3 in our reaction. 1 and 3 is B. Question number 29 is B. Now, question number 30. Question number 30. Select the statements. Select which statement is or are correct or are true. Sorry, about the formation of sodium chloride. About the formation of sodium chloride. Okay, sodium ion loses ion. Sodium ion loses 1 electron. It doesn't work like that. For sodium chloride to be formed, ion will not lose electrons. It doesn't work. The chloride ion gains 1 electron. No, it's not the chloride ion that gains electron. It's the atom that will gain an electron. On the same thing with sodium is the atom that will lose an electron. So 1 and 2 wrong. 3. The sodium gains an electron from chlorine. Opposite. It is chlorine that gains from sodium, not sodium gaining from. So that one is opposite. 1, 2, and 3 are wrong. 4. Sodium and chloride ions are formed. Very good. Sodium and chloride ions are formed in the formation of sodium chloride. You are right, because sodium, which is the solid, will lose an electron to form a sodium ion. To form a sodium ion in aqueous air plus, that one will lose an electron. Then chlorine, the chlorine will gain electron. Chlorine will gain an electron to form what we call the chloride ion. So the chloride ion and the sodium ion, this one, okay, the sodium ion and the chloride ion are the one that will give what we call sodium chloride. So we say sodium chloride ion are formed. In that case, we are taking 4. 4 sodium and chloride ion are formed. When sodium loses an electron, an ion is formed. When chlorine gains an electron, an ion is formed. So the ions are formed as I've indicated them here. In that case, 4 is the right answer. And 4, looking at our answer column, 4 is D. 4 is D. 4 is D. Okay, number 31. Which of the following industrial processes involve the use of electrolysis? Industrial processes involve the use of electrolysis. Okay, electroplating. In electroplating, that's good. You are electroplating like a sieve, like spoon, all those things. It involves electrolysis. Good. The manufacture of sodium hydroxide does not involve electrolysis. Extraction of aluminum, it involves electrolysis. So 1 and 3 are right. Extraction of copper does not involve electrolysis. So the only industrial processes is electroplating and the extraction of aluminum that will involve electrolysis. And that is 1 and 3. And if we check 1 and 3 on our answer column, 1 and 3 is 1 and 3 is B. 1 and 3 is B. So question 31 is B. 31 is B. It's only aluminum and electroplating. Number 32. State one common property of metals. One common property of metals. You know, we say metals are brittle, they can do this, they conduct electricity. Brittle, yes. Electrical conductivity, yes. But the most common one that we use metals are what? That the metals they have is what? Electrical conductivity. So our answer is C. That is C for 32. Question number 33. A compound X gives a golden yellow flame. That is a flame. A color X gives a golden yellow flame. On addition of dilute hydrochloric acid to the compound, a gas is evolved that turns lime water murky. So, for a gas to give for a gas to give a golden yellow flame under the Bunsen burner, it should be sodium, because sodium is the one that gives sodium ion is the one that gives a golden yellow flame. So the compound must contain sodium ion. Secondly, addition of diluted hydrochloric acid to it gives a gas that turns lime water mercury. Then that compound again, the thing is, it must contain a compound that contains sodium atom, or what we call sodium ion. Then to produce only carbon dioxide can turn lime water murky. And to produce carbon dioxide, that compound must contain a carbonate. There's one thing. Sodium ion, then that compound again must contain a carbonate that will produce carbon dioxide. Therefore, let's check our compounds. It is not potassium sulfite. No. It is not. There are two sodium. It is not sodium sulfite. No. I mean sulfate. Sodium sulfate cannot produce a gas that will turn lime water murky. No. Potassium carbonate. Potassium carbonate does not have. Is not potassium carbonate. It does not. Potassium is lilac, not golden yellow. So there is sodium carbonate here, and sodium carbonate, it has sodium, it will produce sodium ion, and there is a carbonate that will produce carbon dioxide. So B is the right answer. Three is the answer is B. 34. Question number 34. Question number 34. Determine the molar mass of ammonium nitrate. Determine the molar mass of ammonium nitrate. The molar mass of ammonium nitrate is to determine the molar mass of ammonium nitrate, we will have nitrogen, ammonium nitrate, that is nitrogen times 2. There are 2 nitrogen, there are 14 times 2. Plus there are 3 oxygen there, 16 times 3. Plus 4 hydrogen there is 1 times 4. And if we do this, we will have 80 gram per mole. So with 80 gram per mole. So now our answer is C. 34 is C. Now, the following setup was used to study the reaction between magnesium carbonate and dilute hydrochloric acid. We have the test tube, the conical flask there with magnesium carbonate with dilute hydrochloric acid. Okay, on a balance, the reaction is going on. The reaction is going on with a cotton wool. Gas is being produced, of course. Gas is being produced. The gas is being produced. This is the reaction. The reaction there is magnesium carbonate plus 2 hydrochloric acid to give magnesium carbonate to give magnesium. A salt is formed. Magnesium chloride plus, that is aqueous, plus water, plus carbon dioxide. A gas is being produced. There's a gas here, aqueous, and there's liquid here. There's aqueous. There was solid here. Yeah. Okay, now a gas is being produced. This gas does what? Is escaping through the cotton wool out. What is happening? There is a constant mass here. There is a balance. This is a balance. Now, as the reaction is proceeding, more of the carbon dioxide is being produced. More of the carbon dioxide is being produced. Water is being produced. Magnesium chloride, the salt, is being produced. But magnesium chloride and the water will remain. There is a gas that is escaping. See the cotton wool there. Allow the gas to leave. They are telling us, why is there a gradual loss in mass? The carbonate dissolves. No. The carbonate decomposes. No. Less product is produced. No. Carbon dioxide escape. Yeah, it's the carbon dioxide that is escaping. As the carbon dioxide is escaping, the mass is dropping. So our answer is D. 35 is D. Question number 36. Question number 36. Why is dilute sulfuric acid not suitable for use in this experiment? The same experiment with the dilute sulfuric acid. Let me say if I have to write an equation for dilute sulfuric acid, if I have to write the equation for dilute sulfuric acid, I will use this. There is a magnesium carbonate. Magnesium carbonate plus sulfuric acid is dilute. We will have magnesium sulfate, a salt is being formed. Magnesium sulfate plus water again, then plus carbon dioxide. But remember, this salt is insoluble. The magnesium sulfate salt is insoluble. This salt is insoluble. Let's go back to our equation and answer it. We have a salt that is being formed. Okay, our question says, why is dilute sulfuric acid not suitable for this reaction? I will say dilute sulfuric acid is not suitable for this reaction because the magnesium sulfate, which I have just indicated here, the magnesium sulfate salt that is formed from the reaction from the reaction with sulfuric acid is insoluble in water. Is insoluble in water and will cover the magnesium carbonate, causing the reaction to stop. This magnesium sulfate that has been formed is insoluble in this water. It is insoluble in the water there. The magnesium sulfate is insoluble in the water there. For that purpose, the magnesium sulfate that is being produced from the reaction with sulfuric acid will cover this magnesium carbonate. It will cover the magnesium carbonate, causing this reaction to stop. Let's go to our answer column. Question number 36. Why is the sulfuric acid not suitable for the use in this? A. Sulfuric acid forms an insoluble salt. Simple. Sulfuric acid will form an insoluble salt, and the insoluble salt is what? Is magnesium sulfate. Magnesium sulfuric acid is less reactive. Magnesium is very soluble. No, the answer is A. So, as I told you, read the question, diagnose it, deduce possible answers before visiting the answers that have been given by the examiner. Okay. 37. Which of the following substances will form a colored precipitate with aqueous sodium hydroxide? Reaction, we have reactions with ammonia, aqueous ammonia. We have reaction with aqueous ammonia, aqueous sodium hydroxide. But you can notice that reaction. You can notice that reaction with calcium Yeah, they are precipitate that will be formed, but they have said colored precipitate. Colored precipitate. We lead may not colored with sodium not colored. The only substance that can yield a colored solution or a colored solution resulting in a precipitate. The only substance that will result in a colored precipitate when reacted with aqueous sodium hydroxide is copper sulfate. First of all, copper is colored blue. When reacted when it reacts with sodium chloride, the color precipitate emanates. Therefore, the right answer here is copper sulfate. D. Answer question number 3.8. Why is sulfur trioxide not dissolved directly in water in the manufacture of sulfuric acid? Why is sulfur dioxide not dissolved directly in the manufacture of sulfuric acid? Well, sulfur trioxide, we have, this is a gas. Sulfur trioxide, a gas plus, well, if we react sulfur trioxide in water, let me see, we are going to have sulfuric acid. If we react sulfur trioxide in water directly, we will have sulfuric acid. But that is not the case. That is not always the case. If we do this from the reaction, we will have sulfuric acid. But that is not the case. The reason is this. If sulfur trioxide is added directly to water, sulfuric acid is being produced, but the reaction is very exothermic. And the heat that is being given off is sufficient enough to vaporize the formed acid. And a thick mist is being produced that makes it very difficult for the acid to be collected. I am saying that it is possible, but it is not the case because the reaction is very exothermic and the heat given off is sufficient enough to vaporize the acid that has been formed, and a thick mist is produced. That makes it very difficult for the acid to be recollected. So if we visit our answer column, we will see that the answer here is sulfur trioxide is not very soluble in water. No, the reaction is violent and highly exothermic. That is the answer. B is the right answer. Question number 39. In acid-base titration, 20 cm³ of dilute hydrochloric acid were required to neutralize 25 cm³ of 0.1 molar sodium carbonate solution. Determine the molarity of the dilute hydrochloric acid. It is very simple. You have got this here. You have the listing of the acid of the base has been given. Everything regarding the acid has been given and the base, but only the molarity of the base that has not been given. Okay, we can use, there is a formula we have in calculating this. There is a formula we can say molarity of acid. We can say this as, the first thing you do here in this type of reaction is, for titration, a balanced chemical equation is required. So we have sodium carbonate plus hydrochloric acid, yes, 2 is a salt that is being formed, plus water, plus carbon dioxide. Salt and carbon dioxide is being produced. It's always good to write the state as solid, aqueous, liquid, and gas. but this I'm just doing for calculation. Use the formula, please. For this, you can use this formula. Let me say I will use only method 1 here. I will say molarity of acid, volume of acid, molarity of base, volume of base, and now the mole ratio of acid and the base. Now we will go now again. We can now say we are looking for, all these have been given. What we are looking for is the molarity of the base, the molarity of the acid. So the molarity of the acid is what we are looking for. This is what we are looking for. Therefore, molarity of the acid here now becomes the molarity of the acid now Ma. We rearrange the equation. Ma will be equal to what? Mb Vb A divided by Va and B. Now, the volume of the acid was what? The volume of the acid is 20, were given as 20 centimeter cube. And 20 centimeter cube in dm cube is what? Is 0.02 dm cube. Then, the molarity of the acid, we don't know, we don't have it, but the volume of the base was what? Is 25 cm cube that was titrated into, that was pipetted into the conical flask, cm cube. And if we divide it by 1,000 into dm cube, we will have what? We'll have 0.025 dm cube. Now, the molarity of the base is what? Mb. Mb was given as 0.1 molar. And A is what? The acid is the mole ratio. Look at the equation you have written. How many moles of A are reacting? How many moles of acid? We have 2 moles of acid. A is acid. Then B, how many moles of the base? Is only 1 mole. So it's 1. That's the mole ratio I am talking of. Now, if we substitute our values here, we will have 0.1. These values, we will have 0.1 times 0.025 times 2 divided by Va is 0.02 times mole ratio of the base is 1. And what will be our Ma? The molarity of our acid will be what? 0.25 molar hydrochloric acid. And if we do this, we go to our answer column, 0.25. 0.25 there, that is question number 39. 0.25, our answer here is C. C is the right answer. 39. Okay, now question number 40. Question number 40. Question number 42. W and V have electronic configuration. W is 2, has the electronic configuration of 2, 8, and 1. V has electronic configuration of 2 and 6. Write the formula of the compound formed between W and V. Okay, I have to analyze this to you, as I told you. To analyze this, what we need to do to analyze this, I told you, okay, remember that group 1, they have a charge of 1 plus. Group 2, they have a charge of 2 plus. Group 3, they have a charge of 3 plus. 3 plus. Group 4, they have a charge of group 4, they have a charge of group 4, we don't consider because they only undergo covalent bond. They go by the covalent bond. So group 4, no charge is there. Group 5, they have a charge. Group 5, they have a charge of 3 minus. And group 6, they have a charge of equals to what? 2 minus. Group 7, they have a charge of group 7, or the modern periodic table calls it group 17. Group 7, they have a charge of 1 minus. Now, plus 1, a charge of plus 1 corresponds to 1 electron that is lost. A charge of plus 2, 2 electron lost. 3 electron lost. Then all these electrons are lost to obtain an octet of electron, a full octet of electron. So a charge of minus 3 for group 7, for group 5, shows that 3 electrons they need 3 electrons, or 3 electrons are gained to complete its outer electron shell. Group 6, 2 minus, shows that 2 electrons are gained to complete electron shell. And group 7, 1 minus, shows that 1 electron is gained to obtain a full octet of electron. Now, analyzing what was given, W, from this W, we have we have W from the answer, from the question. W is 281. 1 electron means that it has only 1 electron in the outermost shell, and this belongs to group 1. Therefore, W belongs to group 1. W is group 1, and it has a charge of what? Plus 1, or 1 plus. Then V is equals to, belongs to what? Look at the electronic configuration. Is 2 and 6. 6 electrons in outermost shell. It means that it belongs to group 6 of the periodic table. And if it belongs to group 6 of the periodic table, it has a charge of what? Negative 2. It belongs to group 6. And if it is group 6, it means it has a charge of negative 2. Now, to have a formula between these two, there is a method. The simplest method you can easily understand will be, this is W and this is V. Their charges are, so a charge of plus 1 plus is a charge of plus. A charge of 2 minus, we'll put the charge 2 minus here. So now, the only way you can do it, I don't want to go to method number 2 because of time. We need to swap their charges. They swap the number of their charges. So this will come here, 2 will go to W, and plus 1 will go here. So now W will have a 2, so it will be W 2. Then V will have a plus, 1 plus. 1 plus is just 1. So W will have a 2 from that comes from V, and V only 1 goes to V, and it's only 1. There's not rewriting 1. So we can now say the formula is W to V. You can do the second method. You can do it like this. The ions are W plus and V 2 plus. 2 minus. Now, to cancel out these ions, there must be 2 plus and negative 2 minus. So we have to add these 2 again here. There must be W minus. So if we add this, total will be what? It will be 2 plus. So now we don't add anything here. We come here, the total will still remain what? 2 minus. 2 minus. So therefore, we can now summarize this, that how many of the W are here? 2. W 2. How many of the V are here? It's only 1. So in that case, it is still the formula. That's method number 2. So if we go back to our answer column, what will be our answer? Our answer will be 40 is A. Write an equation for the reaction between hydrogen and V. Hydrogen and V. Hydrogen and V. This is hydrogen. Hydrogen and V. Hydrogen and V. One hydrogen, and this is hydrogen and V. Okay, for hydrogen is hydrogen. a hydrogen is 2 plus a V. V, I said V belong to group 6. These are always like a dimolecule, a molecule, not single atom. So now will be like a molecule, not single atom. So now it will be V2. So V2, we will form what? Okay, between hydrogen, again, before I come to the answer, again, between hydrogen, the bond that can be formed between hydrogen and V. D is hydrogen. D is hydrogen and V. I told you that this one has a charge of what? Plus 1, and the other has a charge of what? Negative 2. 2 minus. So let's swap the charges. And let's swap the charges. You will see that hydrogen will take what? Hydrogen will be H2. And V will be what? V will just be the one from this. So this will be the product. So that will definitely be the product. It will be H2. The product will be H. Excuse me. The product will be H2 V. Let's balance our equation. There is 2 here and there is 2 here. There is 2 V here. So we need to balance our equation here. Put a 2 here. Now there are 2. There are 2 V's. There are 2 V's here. Hydrogen, there are only 2. There are 4 hydrogen here. So we put a 2 here. Okay. Let's see if we have an equation like this one in our answer column. Our answer column, let's see if we have an equation like that. Hydrogen plus a V will give us this. Our answer is A. So A is the right answer for question number 41. A is the right answer. Question number 41. A is the right answer. 42. Which of the following is a mixture? Which of the following is a mixture? 42. Which of the following? Common salt. Let me tell you, a mixture. What is a mixture? A mixture contains 2 or more elements or compounds in different proportion. A mixture must not be equal amount. We cannot say 4 grams plus 4 grams. No. I say a mixture contains 2 or more elements or compounds in different proportion. They must not be equal. Again, a mixture do not have a chemical formula. Mixture contains 2 or more elements or compounds in different proportion. Mixture do not have a chemical formula. Example of common mixture are a mixture is seawater is a mixture, air is a mixture. For that purpose, let's visit our answer column. Which of the following is a mixture? Common salt. Common salt is sodium chloride. It has a formula, so it is not acceptable. Sodium bicarbonate, it has a formula, so it is not acceptable. Liquid ammonia, ammonia has a formula, so it is not acceptable. So seawater, which I earlier gave, that is an example of a mixture. Seawater and air, these are all examples of air. Is our answer. D is the right answer. Okay. Number 43. Hydrocarbon contains 9.25 gram of carbon and 0.75 gram of hydrogen. Determine the empirical formula of the compound. Very simple. Very, very simple. Very simple as you think. We have carbon. We have carbon. We have carbon and we have a hydrogen. And the masses are 9.25 and 9.25 and 0.75. These are all their masses in grams. Then we want to have the number of moles. The number of moles is divide this by their relative atomic masses. The AR what? Relative atomic mass for carbon is 12. We put a 12 there, 12 gram per mole. Relative atomic mass for hydrogen is 1. And if we divide this, what will be the outcome? The outcome here will be 0.771. These are the number of moles. 0.75 remains 0.75. These are moles. Now, in order to have our final answer, we need to divide it by the smaller. The smaller one is what? Is 0.75. Divide it by 0.75, 0.75, 0.75. If we divide this, we approximate it, it will be 1:1. So 1:1 will be C:H, and giving us an empirical formula of CH. When you solve such a problem, you now visit your answer column to see whether your answer corresponds with any of the answers. So now it is CH, and CH here we have CH2, A is CH2, B is CH, C is C2, D is C2H4. So based on our calculation, our answer is B. The last one, which is 44, because for time limitation, last one is 44. Which of the following is the best procedure for diluting an acid in the laboratory? I told you that acid is more dense than water. Acid is heavier than water. Concentrated acid is heavier than water. In order to prepare acid in the laboratory, it is not good. If we pour acid is less dense than water. Acid is more dense than water, sorry. In other words, acid is heavier than water. Water is less dense. If we pour water, note, if we pour water on the acid, in the course of diluting it, if we pour water on the acid, because water is less dense, water will flow on it, will flow on the acid. There will be a reaction that can result in that is hazardous. The acid can splash, the heated water can splash back on you as a result of the water between the acid, reaction between acid and the water. But if we pour acid on water, acid is heavier now. If we now pour acid on water now, because acid is more dense than water, because acid is more dense than water, acid will diffuse easily into the water. The diffusion will be easy and there will be no splashing. It will not be hazardous. So for safety reason, acid is added but on water. Acid is added but on water. Because it is more dense than water, acid is added but on water when diluting an acid in the laboratory for safety reason. For our answer column, the water is poured into a beaker containing acid. No. In this case, you are adding acid on water. No. The water is added to a known volume of acid. No. A known volume of acid is added to water. That is the right answer. I said acid is added but on a measured on water. A known volume that you need to dilute need to be added but on to the a known volume of the acid is added to water. So our right answer this is a C. That is for safety reason. Those working in the laboratory, it's not advisable to add water on the acid. It will splash on you. Water is less dense and it will splash. So it's preferable a known volume of the acid is added to the water. There will be easy diffusion. Thank you very much for limitation of time. That is the level we can go. Thank you, thank you, thank you very much for listening. Our fellow learners, I want to thank you for your time you have taken to subscribe to our channel. For those of you who have not subscribed to our channel, please take your time and subscribe to our channel. It will motivate us to keep on helping you people. But do not go without hitting the notification bell. Thank you once more for listening. Wishing you best of luck in your exams.